Okay, hi everyone. This is Joshua Goosen. This is my presentation on my development project. I've called my development project PiYing projection mapping, and it's focused on bringing projection mapping to small scale theaters, or really could be anything, any organization small in scale. Could be your own home. It could be a school. I'm focused on small scale theater because I actually get to work with a circus school. This is just pictures from my awkward aerial Instagram account. Years ago, I used to do back end stuff in lighting, sound, and projection and video. But after that, I went and got a degree in computer science. So kind of left that behind, and after I got tired of working with computers, I joined the circus. And I bring this up because I enjoy showing pictures of myself, and because really a lot of you have been asking questions, those of you who've been reviewing the papers on how does this relate to education. I think this demonstrates how really education is everywhere. A lot of you work at an office. I work at an office too. People have to know how to properly build things or work on things in an office. So there's clearly a lot of education there. Clearly, education is part of our school system. But if you think about the arts, somebody has to teach people how to perform. Somebody has to teach people how to build together stage presentations. Communication clearly is a part of everything that we do as human beings in any social context, at least. And so by bringing projection mapping to this small theater school, we're really on multiple levels demonstrating how this simple communication method that's fundamental, again, can be used across many different potential environments. So some additional background on really what projection mapping is and the history of the technology. I mean, for an in-depth look, I definitely recommend reaching out to me or taking a look at some of the documents I've posted up on Georgia Tech sites. But a quick flyover. Basically, this is all a continuation of really old technology, like everything. Years ago, they'd use firelight to cast shadows and using leather in China. You can see that on the right side, and that's called PiYing, where we get the name of our project, in addition to being related to Python. Also, that's a fundamental allegory, Plato's cave, which gives the indication to me that this is an ancient human practice of just projection, whether it's projecting shadows or projecting light, to then use as storytelling. And any of you who have gone to, I imagine in high school, elementary, all the way up, projection now is done with LCDs and DLPs. Some of you might remember glass and mirrors, and some of you might remember slides, and of course all of us had videos. All of those are related technologies to this early form of projection, and now everything is LCD, DLP, because there's a high degree of control. We can map pixels now to where we're throwing things. That enables Disney and the Metropolitan Opera and other organizations to build really cool presentations where it looks like we're not projecting on the usual rectangular space. Now these projections can surround people, and we can create immersive experiences. So it almost feels like you're in the TV or in the video. Of course, a lot of overlap with augmented reality. a lot of complexity, a lot of mathematics, a lot of programming involved. If you're talking just about warping images, that goes back hundreds of years, but each version of technology creates a new warping images challenge. We are clearly not working for Disney, although I have worked for Disney, and I know their implementations cost $500,000 up. What we're trying to do is to disrupt that market where only big, powerful players can build these solutions. We're trying to make a free solution and liberate the technology using Python, OpenCV, NumPy, SQLite, OpenGL systems. You still need hardware components. So in our case, we're using an in-focus projector, lens tech webcam, and a 64-bit Windows machine. However, all of these hardware components you can find for hundreds of dollars instead of thousands of dollars, sometimes even less. And then, of course, we're proposing unique software components. So for the rest of this presentation, I'm just going to show that I've been working on this and show some of the pictures and map those, of course, to the deliverables. So the first week, I put together all the hardware. This is the projector on the right-hand side. I think that you can see the camera in between and the laptop. To be honest, I haven't really used the projector much. I'm not there yet, but I've configured the platform for Python. I've confirmed that it's working following the path initially planned. And on the right-hand side, you can see actually a mini stage I've created where my TV would go. And I bought a few styrofoam pieces to play with. Now, already this is projection mapping, technically speaking, but I haven't actually mapped it. I'm just throwing the usual rectangular screen onto my stage so you can see kind of this picture just happening to be projected onto these shapes. These are actual 3D styrofoam pieces in my living room. And I believe we're at week 2. I've actually, to test this particular system, there's a whole bunch of OpenCV code. So I built the development environment, I threw the code into files, I made adjustments. Most of the adjustments are just making sure you map the your camera is given a number in OpenCV, so you need to map that number to the code in Python once you've configured Python, and that enables you then to use the code. You download it just mostly just as it is. You might have to make a few additional adjustments, but you can see really the power that OpenCV brings to this. OpenCV is something Intel developed, and they were nice enough to give away for free. Join the revolution, because they weren't in the business of making software, they're in the business of making hardware. So they developed some software packages to demonstrate their hardware capabilities, threw it out in the public domain. MIT, Georgia Tech, most major universities have played some role in either using or developing some of these components, along with Python, so that people like you and me don't depend on large corporations to get work done. Some of these are funny. Some of these are really interesting. Facial recognition out of the box. You throw some code in and it recognizes faces. There's some complex statistics going on behind the scenes, but OpenCV eliminates that. I remember doing the estimate for how much this would cost to build back around 2001. Again, thanks to processor advancements, thanks to Python advancements, thanks to OpenCV advancements, we no longer have to make this stuff so that it only works for our particular webcam, and we had to jump through months and potentially years of algorithmic development so that we can do facial recognition. Now you simply reuse some libraries, you drop some frames in, you manipulate the camera, and using really just a few lines of code, which I'll show in the next screen, you can do really cool things. Blending is going to be important, and there's different types of blending. This is kind of blending of my image on itself to create this ghastly effect. But I think blending is going to be really important when we want to throw, because it gives us the capacity, and this has really got me interested, of throwing video onto things. So I want to only throw a video of stars onto a particular background so I can create a nice stage for a performer. I can do that now. Warping, this is a fun image here. And then there's some more advanced AI stuff we can get into down the road if we want to, or just movement detection and edge detection. This particular security. Hey, quiet. This particular security feed is demonstrating that it can detect when an object is moving in space. But there's a lot more. There's just many more potential uses for this. I know this is being used right now in artificial intelligence for robots walking around rooms, identifying things, just as one example. Final slide, I'm showing just the complexity of the code. It's really simple. I could hide this stuff and say, look, I'm a really cool, smart programmer guy, but realistically, I am taking the easiest way out, and I think I want to share that because I think this is technology I want people at the school to use, or to feel like they can use, or people that, again, I'm making this available to schools. I want people in schools to know this is really easy to use, to just project myself into a square. I'm looking at, there's a few other paragraphs of code, but more or less a page of code. That's fantastic. Again, 10, 20 years ago, this would have been, to do this same work, you would have been building thousands of pages of code potentially, and spending months doing, potentially even working on this at the mathematical level. I'm okay at math. I don't see myself working for months at a time on math projects. So especially for a school project like this, this makes some really nice technology accessible so that you and I can use it as students. Again, this is education driven. Students that are placed on semester time limits, but also hopefully we can build something that people outside of technology can actually use. I'm looking again at theater people that don't know what code is and have the slightest clue about projecting matrices, or applying transformations to matrices in a computer. They wouldn't know where to begin. Anyhow, just wanted to thank everybody for taking a few minutes to look at this presentation, and looking forward to seeing yours. Thank you.